Hello everyone, this is Jatin again. Today we are going to practically see the impulse response of an RC circuit.
So here we have an RC circuit. It consists of a resistance of 1 kilo ohms and a capacitance of 1 microfarad. These two probes provides the input to the RC circuit, and through these two wires we fetch the output out on the oscilloscope. As an input, we give impulses at regular intervals to the RC circuit. You can see these sharp, narrow pulses here on your screen. We know that the impulse response of an RC circuit is an exponentially decaying function. Since we have given impulse as an input to the RC circuit, on the oscilloscope we observe that the output is indeed an exponentially decaying function, showing that if any system is given impulse as an input, then the output is the system's impulse response.
Talking about impulses, not only in electrical systems but in everyday life, like things happening around us, we observe impulse and their impulse responses. Let's take up some of those examples.
So as Jatin has mentioned, there are a lot of real life examples of impulses. I'm Megesham. I'm going to talk about some of these real life examples now. So you have seen a nail and a hammer. So you have a nail and you have a hammer. So when you hammer the nail as such, the contact of the nail and the hammer is just for a few milliseconds, but the momentum or the force that you impact in that few seconds is really large. So you can consider this as an impulse being given to the nail. And you have seen in most of these movies, the guy gets a heart attack and then they do a defibrillator and then they kickstart the heart. So let me just talk about this once. You have a battery here, you have a battery and you have two switches which will connect the battery to a capacitor. There is an inductor and there is one more switch, and then here you have the patient's heart. So what you do in a defibrillator is, you have the battery, then you charge the capacitor and then you open the switches. Now it's totally charged. Now it's charged. So the guy is holding the defibrillator. As soon as he places it across the heart and then jump starts the heart. So what it does is you close the switch, it completes a circuit between the capacitor and the heart, and all the energy across this given to the heart as an impulse. So basically that's why you call it kick-starting the heart. And let's get to one more example. The other examples would be, most of you might have seen your parents or you yourself might be having cars. So when you switch on the car with a key, so the engine, how it starts is basically a small spark comes when you switch on the key, and this spark starts the engine. And then it's similar with tube lights. So if you have a tube light with a spark plug, so what it does is it gives a small spark to start the tube light. That's also can be considered as an impulse. And let's talk about momentum change now. Suppose a guy is traveling in a car and he's traveling real fast. Suppose a guy is traveling in a car and he's traveling real fast, and then I don't know, maybe he didn't watch it, but he meets a brick wall, and then the car just comes to a stop. I mean, it's damaged, but say the car has a mass m and it's moving at a velocity v, and then as soon as it hits the brick wall, it comes to a stop. Say the car has a mass m and it's moving with a velocity v, and then as soon as the car, so let's say the car has a mass m and a velocity v, it's moving and then it hits a brick wall. So the car crashes, but it goes from velocity v to 0 after it crashes. It's 0 obviously in a few milliseconds. So the momentum which was first mv, it's now 0. So if the car is moving really fast, say at 60 miles per hour, and cars weigh 2 tons or something like that, which is 2000 kilos. So the momentum change, the change of momentum from it's moving, let's say assume it's moving at a constant speed, the momentum change from this to 0 and this time here is very less, milliseconds, less than that. because you just hit a brick wall. Now, if you look at the change of momentum, this would be an impulse. Momentum just went from being so high to zero. How many of you have just got a shock, like, or touched a burning pan, then you just retrieve your hand back, because the neurons, they actually send an electrical impulse to the brain saying, oh, I touched something bad, just get back. Or when somebody tries to hit you, you'll like close your face altogether, because it's kind of you get all these impulses in everyday life. Your body is basically made up of electrical impulses. So the signals the body sends you, the touch, the tap, these are all electrical impulses. So your body is made up of electrical impulses. Impulses practically make a lot of sense, but I need to mention this thing. An ideal impulse will not exist practically, because an ideal impulse is infinity at a single point. So practically we say impulse is something, a signal which has high amount of energy, or not high amount of energy, a signal which has high value in a very less amount of time. And impulses can be in many domains. Now you have seen impulses in time. How does an impulse in frequency look like? You'll get to know more about this when we talk about Fourier transform, because a pure sinusoid is an impulse in frequency domain. So when you talk about impulse, ask in which domain, because a spark plug, it's an impulse as an input, but how? Is it impulse in time? Is it impulse in heat? So an impulse is basically a signal which is really high in a really small range of the base unit we are considering. The base unit can be time, frequency, I mean whatever. So I've given you some examples of impulses which occur in practical life, and now impulses are there everywhere, you just have to notice them. I'd like to see you guys discussing on the forums on what can be impulses and what cannot be impulses, and thank you very much.